So lecture 3, let's go over to the first module and download the lecture note. Okay, this is our lecture notes to start with. Okay, and we can start the presentation. And also, I want you to start your SIMIO software. And it's very easy, almost similar to the last lecture period we're going to go over with you. And I hope you can join me to exercise one more time to get used to the SIMIO workflow, SIMIO user interface. All right, it's a little bit slow. All right, so this is as we talked about, we showed before. This is initial blank model, and we're going to start building another model. We're going to add a little bit more complication into this complexity into this example. So we're going to go for another trial. Okay, the model we have is we have one machine, and one inspection, very similar to the one we exercised last week. As parts coming into the system, follow exponential distribution of 9 minutes on the average. However, this time we have two different job types, okay? And like we said last time as well, we also have two different job type. One we denoted by the green triangle, the other one denoted by the red triangle. But there is a small little twist right here. We only have one stream of arrival this time, which means the 9 minutes including the arrival for both job type, but this arrival have 30% job type 1, which has a priority equals to 1, and 70% of arrival belongs to job type 2 and have a priority of 2. So job type 2 has a lower priority than job type 1. We have 2 workstation, machining workstation, and the inspection station. And the processing time for the machining station, okay, following this. The machining center has a processing time, follow a normal distribution with a mean of 5 minutes for job type 1, with a mean of 4 minutes for job type 2. And they have a standard deviation to define the normal distribution for 2 minutes, standard deviation for job type 1, 1 minute for job type 2. Okay. Inspection station we will have is the processing time follow a triangular distribution. Okay. And minimum possible inspection time 5 minutes, most likely 8 minutes, maximum time is 10 minutes, okay? Also, the outcome of the inspection has 80% of chance that they are confirmed as a good part, go to shipping department, 10% of a 10% of a chance as a scrap, will go to the reject or trash, and 10% of the parts need to rework. So we send it back to the machining station with the lowest priority equals to 3. So up to here, we can start building our model, see if you can follow me. We're going to do a relatively quick. Everybody ready for having the model pulled up? And I will do it slow still. So This time, we will have two machining stations. So I'm going to click on the server and moving one server, another server called inspection. How's that? Not too difficult, right? I'm going to call the first one machine. I'm going to call the second server and click on this text box underneath the server and rename it call inspection. Not too complicated so far, correct? I'm going to line this up a little bit. And then I'm going to have a path connecting machine to the inspection. Is that okay? All right, so zoom up a little bit, just rolling my mouse wheel. And now the outcome of the inspection has three possible outcomes. So I'm going to have several things, sink. So double click on the sink. I have two sink right here. We've done that before. Okay. And get a path moving from the inspection also to the first sink. And the first sink, we're going to rename it shipping. And the second sink, okay, interrupt me if you have a question, okay? Second sink, we're going to call it reject. No questions so far? And also, we will have a third sink, a third path coming out of inspection. We're going to do this like that. Going back to machine. So this is go to shipping, this is go to reject, and this is going back to rework. So we're going to call this rename pass to rework. How's that? All right. So far, no problem? Now, we know that 80% of chance the parts go into the shipping and 10% of chance go to reject, 10% chance going back to machine with the lowest priority. So how do we do that? We've done the last time already. I'm going to zoom in this, click on the path, and the select the weight right here, and select this is 80 or 0.8, it's up to you. I'm going to do 80. And the weight over here is what? 10. And the weight over here is 10. Questions so far? Okay. If not, let's go on. How do I direct the parts based on the weight defined on the link or the path? Click on the blue diamond. This is the output node for the inspection. One more time. Instead of saying output link rule, instead of saying shortest path, I'm going to go by the link weight. Everybody okay with me? Everybody okay with me? Okay, if you're still okay with me, and then this, I need one of the so-called source to generate the incoming parts. So I need a kind of source somewhere here. Why don't I do it up here? So you see that they're distinguished. So here I'm going to say SRC arrival And I'm going to using a path to connect it to machine center. Kind of straightforward so far. And also I need a basically model entity, and this we call the part. So far, okay? Okay. If you're not following this, just, pop up and get my attention. And this part, I said it like before, we have two different pop-up. We have 30% of chance going for type 1, and 70% of a chance priority equals to 2, and also the rework actually priority equals to 3. How do we do that? So here what I have, first I'm going to generate the inter-arrival time right here based on random exponential of 9 minutes. So I'm going to redo this again. All I have to do is type RAN, and you see that automatically highlight the random. All I have to do is hit the dot key. It will prompt me for different distribution. Since this is arrival rate, and we're going to do that exponential. You type EXP or the highlight the exponential, all you have to do is hitting the enter key. It will automatically complete it for you. It also prompts you to need to fill in a mean, which is the average inter-arrival time. And our example will be 9 minutes. Okay, not too difficult. All right, one more time. How do I determine this is 30% and 70%? And also now I'm trying to get the processing time for inspection center and the machining center. So here in the machining center, we can see that the processing time by default is a triangular distribution, but I have a normal distribution. So I'm random, normal, and automatically prompt me, I need to fill in a mean and standard deviation. As we see in the example right here, the processing time is, for type 1 job is 5 minutes on the average, standard with a standard deviation of 2 minutes. Type 2 job is standard deviation of 4 minutes, and with, the average is 4 minutes, standard deviation of 1 minute. So how do I do this? So let's just, for now, just put in 5 and 2 as our input. We're going to change that in a bit. So we don't want to consider all the complicated situations. Just for now, I'm going to put in 5 and 2. 5 minutes on the average, 2 minutes in the standard deviation. Also, inspection station processing time, as we talked about before, is 5 minutes minimum, maximum 10 minutes, between 5 to 10 minutes, most likely it's 8 minutes. So how we're going to change that? Since it's default already triangular distribution, all we have to do is change this. 5 minutes maximum, 8 minutes most likely, 10 minutes maximum. I'm going really slow. If you fall behind or didn't follow, please get my attention. All right.
Yeah. Excuse me.
Who is this?
I'm looking for
Identify yourself.
Simon.
Okay, Simon. Okay.
Yeah.
So when you start speaking, why don't you, since you guys all turn off your camera, so I may not get attention when you start speaking. If you don't want to turn on your camera, that's fine. just say who you are and I have a question. Make sense? So you get my attention. Good, Simon, start. What's going
All
on?
right. I'm wondering about the random that normal 5,2. So, where did you type that? So it was in machine, right?
It's a processing time for the machine.
Oh, because it doesn't propose it to me. Like, it doesn't give me the table with everything that you can enter.
What do
Oh,
you mean?
it does now. Okay, no. All right, it works.
Yeah, we're going to come back to change it later on, because 5 and 2 is just example right now, and we need to distinguish for part type 1 and part type 2. Everybody okay with me so far?
Okay, thank you.
All right, let's do this real quick. So we pretty much have the program done. If I start running this, you can see the parts coming in, get machine process. We can increase the speed of the running, 5, see if it's going faster enough. If not, we do 15 right here, so let's go a little bit faster. If still feeling too slow, I don't have enough time to wait. I need to go to Aggieville, have a drink, so let's do a little bit faster. All right, so here is going a little bit faster, so on and so forth. Okay, so you can adjust the speed if you go 300, so you see that going really fast. Make sense? Okay. Also, now I need to deal with part type 1 and part type 2 for different part type. In the last example, what we have, we just duplicate the source. We have a different parts, different entity colored differently. So we see that coming in with 2 different source. However, this example restrict me, they only come in with a 1 input pattern, arrival pattern, with an exponential distribution with the mean of 9 minutes. It is between these 2 parts. But we do know 30% of the chance the part number belongs to type 1, and the 70% belongs to job type 2. Okay, so we have some a little bit challenge on hand. Let's check it out, how we're going to do this. All right. And also, when the part's going back to rework, which is in the machining center, one more time, type 1 job has a processing time of 3 minutes, standard deviation of 1. So type 2 job rework has average of 2 minutes, standard deviation of 1 minute. So between the new jobs and the rework jobs, and they have 4 different parameters. Is that right? Everybody okay with me? Everybody okay with me? All right. So actually, I need 4 different mean and standard deviation in the machining center. That's really bothers me right now. But here we solve problem one at a time, not in a hurry. So I need to distinguish this part is job type 1 or job type 2. And also I need to determine this job is a new job or it is a rework job. So parts coming through here supposedly equals to the new job. When the part passing through this path, okay, we'll call that path rework, it should be belongs to the rework part. So we need to change. We need some kind of a variable describe the current status or the current representative of this job type part. So go here, we in the model, we want you to click on the model entity up here on your upper right. Are you following me? Okay, make sure you're following. Otherwise, you can spend another 4 hours from home and figure this by yourself. It's probably easier just follow me in the class, and we take half hour, 40 minutes, and we get it learned. But if you feel this is just you sitting into a meeting, getting in class, you just watch me what to do, and you're gonna forget it real soon. Same thing for the online video as well. All right, so let's do this. In the model entity section, we leave the model, we go to the model entity definitions. We're going to define a few things to represent what type of job is this and what type of work status is this. So go to this definition and state. So we're going to define a few things. Okay, we're going to define a few things. First, we're going to define a integer variable represent job type. Okay. I'm getting another integer. I'm going to call this status. Everybody follow what I'm doing? Okay. If you do, so we define two different attributes right here. One called the job type, one called the status, and we could define another one called priority. It gives me arrows right here. It say, well, these things already exist. You cannot call this. So there is existing variable called priority already. Okay, whatever. Let's just hit escape key. I'm going to delete this. They say, how come? I don't see a priority defined right here. Expand this to stay variable, predefined by SIMIO, and you probably see the job model entity priority already automatically defined by the SIMIO. So once you define the entity, there is automatically job priority defined for it. All right, question? If not, we're going to move on. So I define a job type, a status, and I'm going to using priority predefined by SIMIO as a part of the program. So you're going to ask me, what is the difference between this definition for model entity, or we have a same definition for the model as well? All the so-called integer, Boolean, real variable, and string, we're going to exercise quite a bit later on, defined within the model is in the scope for the entire program to see. But if you define it in the model entity, only that particular entity or that particular part has that unique, okay, set of definition. So for example, we go back to the model, go back to the facility. Each one of the parts passing through the system has its private copy or individual private copy of those job type, job status, and priority. Make sense? So jumping anytime, if you have a question, you're going to require to do this very soon in class. What's the time limit? So you better get used to this, okay? We're going to have exam that way. In class exam, you are responsible. So build this without looking for the textbook, watching my video. So it's too late to watch video or read the textbook during the exam. So you should be able to practice with me or practice at home to get some kind of proficiency or the speed on this. All right. So Upon the arrival, I need to decide which type of a job it is. So here what we have, we're going to assign, so parse create arrival based on, this is the process I described one by one in the itemized list. So first we're going to create an arrival, create a parse, follow exponential distribution on the average of 9. I'm going to assign job types equals to 1 or 2 based on 30 and 70 split. Since the status upon arrival is new parts, so I'm going to assign the status equals to 1. For the rework, later on, we're going to assign the status equals to 2. All right. And also, I'm going to assign the priority initially equals to the job type 1 or 2. So we go into the machine and take a possession of the machine based on their priority. I'm going to take possession of the machine, so waiting in the queue and take a possession of the machine. Keep machine for the time required to do the setup and the process. Then I'm going to release the machine for the next waiting job in the queue, if any. The 7 steps, we're waiting according to the priority in the inspector queue, okay? And then try to take the possession of the inspector, keep the inspector for the time required to do the inspection portion, then release the inspector for the next waiting job, if any. Step 11, we're going to split. We're going to branch out for 80%, 10%, 10%, according to their outcome of the inspection. Step number 12, if it's a good part, count the complete job by job type and depart from the system, go to the shipping. If it's reject part, goes to the step 13. Step 13 says count the reject parts and depart from the system. Everybody okay? If it's rework parts, we're going to step 14, assign the job status equals to 2. That represents the rework now. Assign step. All right. How do I define the so-called 30-70% step? Let's do this real quick. We're using a so-called empirical, okay, or in the simulation assignment, we refer as a random discrete. In many real-world situations, you don't have an exact distribution, like normal distribution. We used to know the exponential distribution, the Poisson distribution, the beta distribution. You all learn in step 510 or 511. Many times in the real world, and you do a survey or interview with the foreman or the supervisor on the line, they say, oh, it's about 30-70 split, 30%, 70% split. So you have these kind of rough cut type of a distribution. So how are we going to represent this? Okay, so, and this is going to apply towards our definition of a job type. We're using a so-called cumulative distribution function. So here the syntax looks like this, okay? First value equals to the job type, and that's how many percent the job type 1 is going to be, for example. And then the third value is job type 2, and cumulate up to what? 1.0. So this represents a 30-70 split. If you read this, so job type 1 has a 30% and job type 2 has the rest of a 70%, add up to 100%. Same thing right here, another example for you to try. Job type 1 has how many percent? 20%. Job type 2 have another 30%, add up to 50%. Job type 3 have 40%, add up to 90%. And job type 4 has another 10%, accumulated up to 100%. Everybody understand what's going on? So I'm going to do this in our program. So upon arrival, here I have a so-called state assignment. If you can see that, expand this state assignment right here. For the parts just got created, before it leaves the arrival source, we're going to start assigning stuff. So click on the 3-dot prompt, and it pop up a window like this. We can do assignment, okay? I'm going to wait a little bit so you can get to there. All right. So I'm going to do some assignment before the parts leave the source arrival. I'm going to add one of these. And first, I'm going to, based on assign, model entity, we have job type. See this? So model entity job type. And I need to assign a value. So this value will be either 1 or 2 based on the discrete distribution we just described, okay? That's how we're going to do that. I'm going to start expanding random discrete. You see that? So first is the value 1, replaced by 1. Cumulative probability should be 0.3. Value 2 should be part type 2. And cumulate should be 1.0. That means the rest of the 70% goes here. So now we assign the model entity dot job type, which is we defined it in the model entity objects up here, equals to random discrete, either job type 1, 30%, job type 2, another 70%, add up to 100%. Also, I need to assign the model entity status. So I'm going to search here, call model entity status, should be right here. All right. Model entity job status equals to 1, meaning it is a new job, okay, instead of a rework. Also, I need to assign, like we said it here. Let's go back real quick. Based on this, I need to assign the priority as well. So initially, we're going to assign job type equals to 1 or 2 based on the 30-70 split. Status equals to 1, which is a regular part, and then assigning priority equals to job type. So I'm going to add one more. Model entity, priority. We should have right here somewhere, priority. This is predefined by SIMIO automatically, equals to what? I'm going to start typing, expand it right now, go model entity dot, okay, job type. You don't really have to type all the entire variable name. Many times you just type MOD, it will automatically prompt you, and all you have to do is type JOB, they will automatically highlight that row for you. Okay, so I want you.
Yes, this is Simon again.
Okay.
When I type model entity, I don't find job type nor status, but I can find the last one.
Priority?
I can find priority, but not job type nor status.
Gotcha. Have you defined it in the state over here? You see, I defined these two.
Ooh, I haven't.
Yeah, go ahead, click on the model entity, goes to the definition, click on the states, and start adding two integer state variable called one rename it as a job type, one rename it as a status. We're going to do this all day long, all semester long, so you probably want to follow up on this.
Yeah, I got it now. Thank you.
Not a problem. This class, this demo lecture is meant to be, go back and forth with you, try and error, miss some part, because first time may be overwhelming for you, but after a while, this has become natural for you. All right. Question. Again, don't just watch. Get some hands-on to the model, okay? Otherwise, you are lying to yourself. You're not learning this without doing by yourself. So now you can see that before the parts exiting the arrival block, arrival object, I have 3 rows of assignment. First, I assign the job type, okay, based on the random discrete distribution. Type 1 had 30%, type 2 have the rest of the 70%, add up to 100%. Job status equals to the current status is a new job, so equals to 1. And the priority equals to the job type 1 or 2 based on the previous assignment. And also the assignment sequence is important. You have to assign the job type first, then you can using job type down there as a priority. Otherwise, if your job type was not defined at first, and you have arrows showing up here. Question? And last time, we also did a little bit thing called the parts actually have 2 different job type. One we call one we illustrate as a green, the other one we illustrate as a red. So now I want to do the similar situation. I'm going to zoom in here, just focus on the parts, highlight the parts. You can see that if you go active symbol, you can see that I only have one symbol. I want you to click on add an additional symbol. Now you see this particular entity has 2 different symbols. And you pull it down, symbol 0, symbol 1, they both have the same color. So I'm going to choose symbol 1. For now, I'm going to change color, okay, change color to red. And I'm going to click on the parts right now. And you can see that it becomes red. However, you go back to this active symbol, you can see that symbol 0 equals to green, symbol 1 equals to red. Everybody okay? So this is how it is. we want to be able to also change the color when their job type is changed. So let's do that. I'm going to come to here, click on the arrival first, and I'm going to add a third one called model entity. Let's do that. There is a pictures over here. Model entity dot picture. It represents the symbol using this. So once I have a job type equals to 1 or 2, I shall also change the picture of the parts. But you probably can see that in the symbol for the parts, and it has a 0 to 1 instead of a 1 or 2. What do I do? Can anybody give me a suggestion? What do I do? So job type, initially I assigned a 1 or 2. Okay. Priority equals to 1 or 2 as well. But the picture itself should equals to what? 0 or 1. So what do I do here? Model entity, job type, -1. How's that? Am I going too fast? So here what I have initially assigning job model entity dot job type equals to 1 or 2. Status equals to the 1, new part. Priority equals to the job type, 1 or 2. However, the picture equals to job type -1. So it becomes 0 or 1. So we can see in the model entity portion, you also have automatically defined a picture state variable right here by SIMIO. So I'm just going to use that instead. So now let's take a look how this is going. Not going that fast. So now you see that again, we have a green parts, we have a red part. The green parts equals to job type 1, and the red parts represent job type 2. Question for me.
Can you go back to
Hello?
the model entity job type -1? How it looks like.
Say that again.
Can you go back to the model entity job type -1 and what that looks like again?
Okay. This is what model entity picture.
Okay, thank you.
This is just for animation purpose. You know, if you don't mind, all of them looks green, that's fine. But this is the one more step to confirm that I actually generate both job type. Make sense? Question for me. Okay. If not, I'm going to kind of stop right here, have you digest the model for now and rewatch the video. All right, and then we see how And we'll come back on Thursday, finish this example. I do not want to give too much material in one section. I want you to be able to digest this a little bit. We have 5 more minutes for the class. I'm giving you time to ask possible question you might have. Is this still doable for you on your own? Not too much different from the one we had in last Thursday, but the only thing I want you to understand is we have a little bit more twist into it. First is the different job type coming through using single source, how to define job type, how to change their picture, and also how to define a parts diverted from the inspection, 80%, 70%, 80%, 10%, 10% rework, and then go back to the machining center. The only problem we haven't solved yet is the processing time in the machining processing time for the machine center. We need the 4 different pairs of mean and standard deviation based on the job type and based on the status combined. How we going to do that? So this is the parts we're going to have a twist next time. We're going to spend about 15 to 20 minutes next time to finish this example, show you how to do the so-called processing time. Then we're going to spend another 15 minutes or so next time to talk about our objective, which is later on, I want to determine, let's see that. What do I need to do? Okay, for this job type. The very end, we're going to record how many jobs completed by job type, how many reject we have, how many rework we have. So do some statistic counters and statistic recording or reporting for the simulation model. So you can kind of see the output, and it's showing you where they are in the output tab on the simulation. So the result tab on the simulation portion. So that's the Thursday we're going to do this. Beyond that, we probably going to go the class from the next week, at the beginning from next week. We're going to go through these models real quick. So this class, we just have to let you go slower since this is the second time you see the model. And for the future model, we're going to go a little bit faster every time. So we're assuming you get used to it already. Okay? Any question, please ask, or otherwise you can leave. The class is dismissed.
How did you do the 30% and 70% at the beginning? I think I missed that part.
Who is this?
This is Catherine.
Oh, okay, Catherine. And we did that with a discrete distribution. We're using a random discrete distribution and job type 1 and 30%, job type 2, another 70% add up to 100%. So what we have right here in the source, before they exit the source, we do 4 different assignments. And the first assignment is assigning the job type.
Okay, yeah, I got that one. Sorry.
Okay, is that okay?
Yep.
Cool. I know this is new information. It probably takes a few minutes to digest that, so I don't want to go even further.